Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 7.5, Factoring Special Products. All right, so representing the factoring of a perfect square trinomial. So if we had a squared plus 2ab plus b squared, they're showing us that a squared plus 2ab plus b squared, they're just literally showing you a representation of what this would look like. So I guess this is like A, and this would be like A. So A times A is A squared. A times B is AB. A times B is AB, so there's two ABs. And then this one is the with B, so this is B squared. So just like visually showing you what that would be. Draw dashed lines inside the square below to show how the squares and rectangles from step A could be placed together to form a larger square. Label the dimensions of each part of the length and width of the larger square. So they're literally just showing you, I think they're showing you with this dotted line. If you went like this, you'd have this one and this one here, right? This would be your B and your A and your B. This is B squared right there. That's AB, and this is A squared. Make sense? Do you guys see that? Oh, you don't see it because I didn't shift it up. Sorry about that. So your area, this whole height here would be A plus B. And then this whole part here would be A plus B. So you have A plus B times A plus B. Make sense? Because you have A, this is A, this is B, this right here is A, this right here is B. A plus B times A plus B. How does the model at the right show the factorization of A squared minus 2AB plus B squared is A minus B times A minus B? Okay, so the area of the large square is A squared. The area of the smaller square is A minus B times A minus B. The smaller area is the result of removing two rectangles. Each of which has one dimension of A, because A minus B and B are added together, and one dimension of B. So the area of both rectangles is 2AB, because these areas overlap. The area of the smallest square, b squared, must be added back. Representing the factoring of the difference of two squares. Use the area models to factor a squared minus b squared. Finish labeling this model, a squared minus b squared. Use a and b. So this is a, and this is a, right? That's b. So this is b. Make a drawing that shows the shaded part of the model arranged to show a rectangle. Label each segment of length and width of the rectangle. All right, so let's make a rectangle. So I have that square, and then I have those two rectangular portions. This is B. This is A minus B, and A minus B, right? Because this right here is A minus B. This right here is A minus B. What is the length of the longer side of the rectangle? A plus B, right? Because A minus B plus B, those cancel out, plus B. So A plus B is this whole thing. And then this side is A minus B, right? What is the length of the shorter side of the rectangle? A minus B. So you get A plus B times A minus B. All right, so determine whether each trinomial is a perfect square. If so, factor it. If not, explain why. All right, well, this is a perfect square. This is a perfect square, right? 3 times 3 is 9, and x times x is x squared. So, is this x plus 3 times x plus 3? Well, let's look. X squared plus 3x plus 3x is 6x plus 9. So there is a pattern, a perfect square trinomial. So when it's the same thing repeated, this is a perfect square, this is a perfect square, and this is 2 times them. So x times 3 is 3x, times 2 is 6x. Does that make sense? It's a pattern that you start noticing. Perfect square, perfect square. Is this the 2 times those square roots? Well, let's see. 2x times 5 is 10x, times 2 is 20x. So yes, square root of that, square root of that. 4x squared plus 10x is plus 20x plus 25. You guys see that pattern? So what is this pattern? This pattern is a squared plus 2ab plus b squared equals a plus b squared. Or a squared minus 2ab plus b squared equals a minus b squared. So basically it's just perfect square, perfect square. This is 2 times their square roots, right? Perfect square, yes. Perfect square, yes. That's perfect. The square root of 16 is 4. The square root of 36x squared is 6x squared. So let's see, 6x, 4. It's minus, so let's try this out. 36x squared minus 24x is minus 48x plus 16. This should have been doubled. Is it doubled? No, so it's not a perfect square trinomial. Does that make sense? You guys see how that one doesn't work? It's not a perfect square trinomial. Right? This 24x, it's not 2 times these. It's just these multiplied once. It's not 2 times them, so it's not a perfect square trinomial. Does that make sense? So this does not work. Perfect square, perfect square. Multiply these together times 2. That'd be 6x times 2 is 12x. This is totally going to work. 9x squared minus 6x minus 6x minus 12x plus 4. Right? Do you guys see how that works? Square root, square root, square root times 2. A rectangular fountain in the center of a shopping mall has the following area. The dimensions of the fountain are in the form of that. So write an expression for the perimeter of the fountain. Find the perimeter when x equals 2. Okay, so first we have to factor this. Perfect square, perfect square. 6x times 2 is 12x. We know we're good. All right, so those are your dimensions. So it says the perimeter, wouldn't it just be this times 4, right? Isn't it this plus this plus this plus this, or this times itself 4 times? 8x plus 12 would be the total perimeter, right? So if x is 2, (28) is your total perimeter. Make sense? Determine whether each binomial is a difference of the perfect squares. If so, factor it. Explain. If not, explain. Perfect square, perfect square. Isn't this difference of squares? Difference of squares. X plus 4 times x minus 4, right? Perfect square minus a perfect square is the plus and minus versions of it. How about here? Is that a perfect square? Is that a perfect square? Is 200 a perfect square? No. Perfect square, perfect square. What is the square root of m to the 6th? Well, m to the 6th to the 1/2. 6 to the 1/2 is what? 3. 1 minus m to the 3rd plus m to the 3rd. Middle terms cancel out. Minus m to the 6th. M to the 3rd times m to the 3rd is m to the 6th. There's 6 of them. How about try number 9 on your own? All right, so perfect square, difference of squares. (12s squared, or sorry, 6 times 6 is not 12. 6 times 6 is 36. 36s squared plus 12st minus 12st cancels out, minus 4t squared. You guys do the next one. That's a perfect square. I believe 196 is also a perfect square. It is 14, but it's plus. It's the sum of perfect squares, not the difference of perfect squares, so no, because it's not the difference of perfect squares. No, it's not the difference of squares. It needs to be subtraction. Make sense? Alright guys, so for homework you are going to do page 396 because we actually just did part of your homework. Page 395 was part of your homework. So, because it didn't have like the normal practice problems on this section that they normally have. So your homework is to do the following 6 problems. And then you also have homework from the textbook on page 489, numbers 2 through 26 even, and to review and study for your quiz, which is tomorrow on 7-1 through 7-4. Please do check your answers on Edmodo and have a great day. Please like and subscribe. Goodbye.